One of the most important steps in the construction of any structure or pavement is building the foundation. This is especially true in the construction of roads and highways. The assurance of quality in the materials used is a vital step in providing safe and durable roads for our state. This video outlines the importance of using the standard sampling and testing methods approved by DOTD. Soil is used for embankments, base courses, and as a component of soil cement and other mixtures. Aggregates are also used in a variety of construction materials: asphaltic concrete, Portland cement concrete base courses, and aggregate surface courses, including shoulders. Materials must meet standards for gradation, cleanliness, durability, particle shape, surface texture, absorption, moisture content, soundness, chemical stability, and Atterberg limits before they can be used on a project. The aggregates in a mixture contribute strength and durability to the construction layer. The quality of soil and aggregate must be assured with routine visual inspections and quality assurance tests. Soils and aggregates must be tested and approved prior to use on a DOTD project. Proper sampling is an important step to ensure that the department's standards of quality have been met. All of the given material will be judged based on the results of tests performed on the sample. The sample must accurately represent the material being tested for the test results to be valid. To increase the probability that all the material is properly represented, samples are taken from different parts of the material mass at random locations. As a department inspector, it is your duty to check construction work and materials used on your job to be sure that they meet the standards set by the department. This video will discuss the sampling of soil, aggregates, and aggregate mixtures. Although they are different, soils and aggregates will be discussed together because of the many similarities in sampling techniques. Whatever is said of sampling aggregates can be assumed to be true of soils, unless otherwise noted. Before sampling can begin, you must assemble all the right equipment. The forms and tools used must be appropriate for the type of material and how it is stored. You will always need sampling sacks and string to contain the sample while transporting and storing it before testing. You will need a sampling shovel and shield for sampling from stockpiles, barges, windrows, railroad cars, and trucks. The sampling shovel has upturned sides that prevent the possible loss of material. The shield is used to prevent the movement of unwanted material into the sampling area. It must be strong enough to perform this function without bending or giving way under force. A metal sign can be used as a shield when sampling soils or fine aggregates such as sand. A specially designed shield may be necessary when sampling heavy aggregates such as crushed stones. If moisture content testing will be done from the sample, you will need enough 4-liter, 1-gallon friction-top cans with lids to hold the sample and prevent moisture loss. When sampling soils, you will also need a sealable plastic bag. For aggregates, you will need the Aggregate Test Report, Form number 03-22-0745. Soil samples are documented on the Soils Soil Aggregate Report, Form number 03-22-0723. Now let's move on to the actual sampling procedures. This video will demonstrate sampling from an aggregate stockpile only. The procedure for sampling barges, railroad cars, trucks, etc. is similar. Refer to the Sampling Aggregates, Aggregate Mixtures, and Soils Handbook for more details. First, the total quantity of material in the storage area is a factor in determining the size and number of samples you will need to take. Regardless of the type of storage area from which the samples will be taken, you must first determine the volume of the stored material to be sampled. This may involve physically measuring the storage area and calculating its volume. Refer to the Sampling Aggregates, Aggregate Mixtures, and Soils Handbook for more information on performing material volume calculations. Now, let's move on to the procedure for sampling stockpiles. Keep in mind that a representative sample is composed of material obtained from different locations in the stockpile. At each sample location, you will collect an equal volume of material. The total number of locations used to collect a single sample must conform to the minimum requirements of the material sampling manual. For instance, if you're sampling soil for the acceptance of a dedicated stockpile for a soil cement-based course, the minimum sampling frequency is 1 sample per 1,000 cubic meters of the material. Again, always refer to the material sampling manual for determining the correct sample frequency for the type of sample you're taking. With your sample location selected, begin by inserting the shield upslope from the point of sampling. This prevents loose material from sliding into the sampling area. Remove 75 to 150 millimeters, that's 3 to 6 inches, of material downslope from the shield by scraping the surface with the shovel. The material at the surface is not as representative of the stockpile as material beneath the surface for a couple of reasons. First, fine and coarse aggregates tend to separate on the surface of the stockpile. This process is called segregation. Second, the surface can be more contaminated than the rest of the material. Be sure to expose undisturbed representative material. Holding the sampling shovel perpendicular to the face of the stockpile, insert the shovel into the exposed material. Take the shovel full of material out of the stockpile and place it into the sampling sack. Be sure that you don't overfill the shovel. Repeat until 1/3 of the sample has been obtained. Move to the next location and repeat the process. Take composite samples by obtaining material from 3 different levels of the stockpile: near the top, the middle, and the bottom. Be careful not to contaminate the sample. Avoid sampling from the base of the stockpile, where samples may be mixed with ground soils or contain excess moisture. When sampling at different levels, avoid sampling one area directly above another. This prevents material rolling into the lower sampling area, which is a source of segregation. Composite the material from each level into a single sample to meet the required size. Also, it is a good idea to start sampling at the top of the stockpile. That way you won't have to carry a partially full sample sack uphill. Place material in a sample sack with the appropriate test report form attached. If moisture content is to be determined, the sample must be protected from moisture loss. When you take a sample for moisture content testing, seal it in a clean, dry, friction top can large enough to hold the needed quantity and cover it immediately. This will prevent moisture loss. If you are sampling soils, place the sample in a plastic bag first. Then, put the sealed bag into the friction top can. Remember to close the can immediately. Failure to seal the can will allow moisture to escape, resulting in an invalid moisture content value for the material. The procedures for sampling from conveyor belts and bins are almost identical, so we will cover only sampling from conveyor belts. When sampling from a conveyor belt, in addition to the other sampling equipment already mentioned, you will need a scoop, brush, catch pan, and a special sampling template for the conveyor. Refer to the Sampling Aggregates, Aggregate Mixtures and Soils Handbook for the procedure for determining sampling frequency for conveyors. Once you know the required sampling frequency, wait until the flow onto the belt has stabilized and stop the belt at a randomly selected time. Use a template of proper length and cross-section to obtain the representative sample of proper size. The template must be designed to conform to the shape of the belt being sampled. Using an incorrect template will result in a sample that is the wrong size or not representative of the material. When removing the sample from the belt, be sure to capture all fines. Failure to do so will result in a sample that is not representative of the material. The cross-section of the template must match that of the belt. If the template does not match the cross-section of the belt, gaps between the belt and template will be visible when material is removed from the belt. Material underneath the template also indicates that the template does not fit the belt. Place the template through the material, making sure the template is in contact for the full cross-section of the belt. Remove all material within the template using a brush and pan to remove all fines. Remember that fines are an important part of the material and must be included in the sample. If the quantity of material obtained is less than the quantity required, obtain another sample. When you have finished taking the conveyor sample, place the material in a sample sack with the appropriate test report form. Now we'll sample from the roadway course. See the material sampling manual for determining quantity and frequency of sampling. Samples are taken from 3 of the stations chosen at random, 1/3 from each station location. Dig each hole as vertically as possible and remove material to the full depth of the course. As with the other samples, the amount of material obtained may need to be reduced or another sample taken for the quantity to conform to the requirements of the materials sampling manual. You should now have a much better understanding of soil and aggregate sampling procedures. Remember, valid tests of construction material are made possible by samples that accurately represent the material. Only properly evaluated material can be put to optimal use for construction of a high-performance roadway. Correct sampling is essential for quality road construction. For more detailed information, consult the DOTD Material Sampling Manual, the Testing Procedures Manual, and the Sampling Aggregates, Aggregate Mixtures, and Soils Handbook. Thanks for watching.